Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on implementing Rapid-PVST Plus. So let's go ahead and read our objective for this lab. It says to address the relatively slow transition time of a spanning tree protocol enabled ports to the forwarding state, the Institute of Electrical and Electronics Engineers, IEEE, developed the 802.1W standard, which defines rapid spanning tree. The 802.1W standard was created as a replacement for the STP 802.1D standard. Right here it says, by contrast, per VLAN spanning tree, PVST, is a Cisco proprietary protocol that enables a separate spanning tree to be established for each virtual LAN area network or VLAN. Because PVST can be used to enable separate spanning tree instances per VLAN, the switches in the topology can assume different roles. However, PVST is not capable of using 802.1Q encapsulation to tunnel traffic on a Cisco switch. STP and PVST Plus, on the other hand, can both use 802.1Q encapsulation to tunnel traffic on a Cisco switch. It says Rapid-PVST Plus implements separate rapid spanning tree instances per VLAN. By default, Cisco switches use Rapid per VLAN spanning tree plus. It says in this lab, you will examine and configure a switch network that implements Rapid-PVST Plus. All right. So if we take a look at our lab, we have a host, just one host computer, and then we have a bunch of switches. Of course, we're going to be doing spanning tree in this lab right here. So of course, it's going to put a decent amount of switches within the lab so we can learn a little bit about PVST and spanning tree protocol and Rapid-PVST Plus. Okay, so let's go ahead and read our commands for this lab. We have configure terminal, which enters global configuration mode for privileged exec mode. We have enable, which enters privileged exec mode. We have exit, which exits one level in the menu structure. We have show running config, which displays the active configuration file. We have show spanning tree, which displays parameters for all VLANs, contains the VLAN name, status, and ports assigned to it. We have shutdown and no shutdown. Shutdown, of course, disables an interface, and no shutdown enables that interface. We have spanning tree port fast, which enables port fast on an interface. We have spanning tree VLAN ID priority value. This sets the spanning tree priority value, and the value must be in multiples of 4096. We have the spanning tree VLAN ID root primary. This configures the spanning tree priority value to ensure the switch becomes the root bridge. We have spanning tree VLAN ID root secondary. This configures the spanning tree priority value to ensure the switch becomes the secondary root bridge. So if we take a look at our IP address information, we can see the IP address information for each switch. We can see that each switch is going to have a interface in VLAN 1, and they're all going to be in the 192.168.100.0/24 range, as we can see. And we can also see the IP address of host 1 right here. All right. So this is good information to have as we advance through the lab. All right. So let's go ahead and get into our lab task for this lab right here. It says task number 1, explore Rapid-PVST Plus port roles and configure the root bridge. It says in this task, you will examine the Rapid-PVST Plus topology. You will determine the root bridge and modify priority values to ensure in order to select a new root bridge. All right. So it says allow time for the network to converge. Then on switch 1, switch 2, switch 3, switch 4, switch 5, and switch 6, issue the commands necessary to display spanning tree information. Which switch is the root bridge and how do you know? All right, so let's go to each switch. Starting out on switch 1, let's do an enable. Let's do a show spanning tree. All right, so right here, we can look at this output and tell that switch 1 is the root bridge. It has the default priority of 32,768. Of course, we add 1 for the VLAN, which gives us 32,769. We can see its MAC address. This is switch 1's MAC address right here. We can see hello times, max age times, forward delay times, And then this down here is, of course, this is switch 1's information as well. So it's going to be identical to this address right here because this is the root bridge. So we have identical outputs for the root ID and bridge ID. All right, let's do the same thing on switch 2. We already know what which switch is our root bridge. Let's do an enable. Let's do a show spanning tree. Yes, and as we can see right here, this is switch 1's information for the root ID. And then we can see information specific to this switch. We can see switch 2's priority and MAC address right here. All right, we can see it's hello times, max age times 4 delay times. Do the same thing on switch 3. Let's do an enable. Let's do a show spanning tree. Here is switch 3's bridge ID information. And this is, of course, switch 1's root ID's information. Let's do the same thing on switch 4. Enable, show, spanning tree. All right, here is switch 4's bridge ID information. And here is switch 1's root ID information. Same thing on switch 5. Enable, show, spanning tree. And as we can see, here is switch 5's bridge information ID. And here is switch 1's root ID information. And lastly on switch 6, enable, show, spanning tree. And this is switch 6 bridge ID information. And again, here is switches 1's root ID information. All right. So I just answered that last question, which is which switch is the root bridge? Switch 1 is the root bridge. And how do we know? We're looking at this output right here on switch 1, and it says this is the root. All right. So number 2, it says, based on the output you previously generated, how many VLANs are configured with Rapid-PVST Plus on this switch? Well, we did a show spanning tree, and the only VLAN that came up is VLAN 1. So we're using the default VLAN of VLAN 1, and that is the only VLAN configured on this switch. If we had more VLANs, we will be able to see that VLAN specific information within the show spanning tree command output. All right. So number 3, it says, how does PVST Plus select a root bridge? What do you notice about the priority of each switch in the topology? How does this information factor into root bridge selection? So the root, if we look at the output of the show spanning tree command, we look at the priority. This is the value that is compared first on each switch. And if we looked at each switch, we can tell that the priority of each switch has the default. We can see right here, this is the default for switch 1. This is the default for switch 2, which is 32,768. And then we add 1 for the VLAN, so we get 32,769. So 32,769 on switch 3. Same on switch 4. The same thing on switch 5. And then the same thing on switch 6. So since they all have the same priority, next we compare the MAC address of each switch. And if we look at the MAC address of switch 1, it has a lower MAC address than any other device within a topology. And because of that, switch 1 is selected as the root bridge. All right. So we can see this is switch 1's MAC address. Switch 2's MAC address is right here, which is higher. As you can see, this is switch 1's. This is switch 2's. So switch 1 beats switch 2 out. Same thing on switch 3. This is switch 3's MAC address. This is switch 1's. This is switch 4's MAC address. This is switch 1's, and so on and so forth. So if we look at switch 5 and also switch 6, switch 1 beats out each of those switch MAC addresses as having a lower MAC address. So in that case, switch 1 was selected as our root bridge. All right. So let's go ahead and move on to number 4. It says, based on the output, which switch would become the root bridge for VLAN 1 if switch 1 were to fail? Why and how can you manually influence which switch becomes the root bridge? So if switch 1 was to go out of service, if we compare the MAC addresses of each other switch, so let's go to switch 2. So switch 2 has a 1461. Switch 3 has a lower MAC address, so switch 3 will win now. Switch 3 would win over switch 4. Switch 3 would win over switch 5. And so switch 3 would become the root bridge. Let's see what Boson is going to say. It says, based on the output, you can determine that if switch 1 were to be entirely shut down, then switch 3 will become the root bridge for VLAN 1. And that is what I just said. This is because switch 3 has a MAC address of 000C13803538, which is a lower MAC address than the address of switch 2, switch 4, switch 5, and switch 6. In addition, all the switch priority values remain equal. And yes, we have not adjusted the priority values. So the answer to this question of how can you manually influence which switch becomes the root bridge, well, you can configure the priority value to be lower, and in that case, the switch with the lower priority will become the root bridge. So right here it says to configure a different switch as the root bridge, you should configure a priority value on another switch that is lower than switch 1's priority. Priority values must be decreased or increased in increments of 4096. All right. So number 5, it says examine the show spanning tree output from switch 6. What is the significance of each of the 3 unique port rows on the switch? What would happen if the root port failed? So let's go to switch 6. We're on switch 6 now. And we want to look at the port rows. As we can see, one of our ports on switch 6 is our root port. The other one is a designated port. And we have an alternate port as well. So let's read what Boson is going to say for the significance of each port. It says, based on the output, you can determine that switch 6 has a root port, an alternate port, and a designated port. The root port, which is the fast Ethernet 00 port, provides the best path to the root bridge and is in the forwarding state. The fast Ethernet 01 port is a designated port in the forwarding state. Therefore, the fast Ethernet 01 port forwards traffic from other network segments at the lowest cost. The fast Ethernet 02 port is an alternate port in the blocking state. Alternate ports have a suboptimal path to the root bridge. Alternate ports remain in the blocking state unless the switch root port fails. At that point, the alternate port would take over for the root port. All right, so that's good information to know. So on number 6, it says on switch 6, disable the fast Ethernet 00 port, and that is our root port. All right, so let's see what's going to happen when we do that. Let's do a configure terminal. Let's go into interface fast Ethernet 00. Let's do a shut to that port. Number 7, it says allow time for the network to converge. On switch 6, issue the command necessary to display spanning tree information. What rows are assigned to each port now? So if we do a do show spanning tree, we can see that now the fast Ethernet 02 port is now our root port, and it's in the learning state, and it should be going into the forwarding state here in a second. So yes, now we can see that the fast Ethernet 02 port, which was our alternate port before, is now our root port, and it's in the forwarding state. And the fast Ethernet 01 port is still a designated port, and it's still in the forwarding state as well. So on number 8, it says on switch 6, enable the fast Ethernet 00 port. So let's just do a no shut to bring this port back up. On number 9, it says allow time for the network to converge. On switch 5, decrement the switch's VLAN 1 priority by 1 increment of 4096. What would happen if you miscalculated this value? So let's do, what would that be? Let me bring up my calculator. Bring up the calculator. So we have a value of 32,768 right now. So we want to minus 4,096. So we're going to do a value of 28,672. All right, so let's go to switch 5. And it said, let's do a configure terminal. Let's do a spanning tree. for VLAN 1. Then you want to do a priority. Make sure it wants me to do it. It says on switch 5, decrement the switch's VLAN 1 priority by 1 increment of 4096. So if we miscalculated the value, it will give us an error telling us that we need to do it in increments of 4096. So let me make sure it got 28,672. So 28,672. All right. So number 10, it says allow time for the network to converge. Then on switch 5, issue the command necessary to display spanning tree information for VLAN 1. What is switch 5's priority now? Is switch 5 the root bridge for VLAN 1? Well, let's check the output. Let's do a do show spanning tree. All right. We can see that switch 5 is now the root bridge. It's reporting as the root bridge. All right. Let's take a look at it. Switch 5's priority is 28,673. And that is because it added 1 to 28,672, which is the value we just configured. All right. So it is the root bridge, and we can see its priority right here, which is 28,673. All right. Number 11, it says on switch 5, were to shut down or fail, which switch will be selected as the root bridge for VLAN 1 and why? Well, it will go back to being switch 1 because switch 1 has the lowest MAC address, and all of the other switches, except for switch 5, have the default priority. So if the priority's tied, then we look at the MAC addresses. All right. So let's see what Boson is going to say. It says right here, switch 5 were to shut down, switch 1 would again become the root bridge for VLAN 1. Okay. So number 12, it says on switch 6. Oh, so I didn't mean to highlight all of that. It says on switch 6, issue the command necessary to configure switch 6 as the secondary root switch. Use the command with keywords instead of manually calculating a priority. So let's go to switch 6. All right. Let's do an exit. Let's do spanning tree for VLAN 1, root, secondary. Hit enter there. On 13, it says, allow time for the networks to converge. On switch 6, issue the necessary commands to display spanning tree information for VLAN 1. What is the root bridge status for switch 6 now and why? Okay, if we do a do show, oops, got caps on, do show spanning tree, we can see that switch 6 is actually reporting as the root bridge now. Switch 6 is. Let's see why. It says, based on the output, you can determine that switch 6 is now the root bridge for the topology, not the secondary root bridge. This is because switch 6 has an equal priority to switch 5. The spanning tree VLAN number 1 root secondary command decremented switch 6 priority to a value of 28,672. Issuing that command sets the priority value equal to the one you configured on switch 5. In addition, switch 6 has a lower MAC address than switch 5. Therefore, switch 6 has been selected as the root bridge, not the secondary root. So that is good information to know. So switch 6 actually took over because they have the same priority value now, but switch 6 has a lower MAC address. Okay, makes sense. So number 14 said on switch 5, issue the command necessary to ensure that the switch becomes the root for VLAN 1. Use the keyword instead of manually configuring a priority. So on switch 5, let's go to, let's do a spanning tree VLAN 1 root primary. Hit enter there. And number 15 says allow time for the networks to converge. On switch 6, issue the necessary command to display spanning tree information for VLAN number 1. Which switch is the root bridge now? Which switch will take over as the root bridge if the root bridge currently fails? All right, so on switch 6, let's do a do show spanning tree. And as you can see, switch 6 is not reporting as being the root bridge now. So if we look at switch 5, if we do a do show spanning tree, we can see that switch 5 is now the root bridge. All right. And switch 6 would take over as the root bridge if switch 5 were to fail, because it now has the lower priority value and it has the lower MAC address. So it'd be the next switch in line to become the root bridge. All right, so let's go ahead and move on to task number 2. It says explore Rapid-PVST plus port states and configure port fast. It says in this task, you will explore the port states through which Rapid-PVST, plus ports transition. In addition, you will configure port fast on the Fast Ethernet 011 port on switch 1, which connects to host 1. All steps in this task should be performed on switch number 1. So number 1, it says issue the command necessary to display spanning tree information. In what state are the in what states are the Rapid-PVST plus ports? What are the functions of the forwarding state and the blocking state? So if I go over to switch number 1 and we do a show spanning tree, we can see that the states that we have is the root role, which is in the forwarding state. We have the designated role, which is in the forwarding state. We have an alternate port, which is in the blocking state. We have another designated port, which is in the forwarding state. So let's see what Boson is going to say. It says, based on the output, you can determine that each Rapid-PVST plus port on the switch is in one of 2 states, forwarding or blocking. The Fast Ethernet 00 port is in the root port, and is therefore in the forwarding state. Both the Fast Ethernet 01 port and the Fast Ethernet 011 port are designated ports and in the forwarding state. The Fast Ethernet 02 port is an alternate port and is therefore in the blocking state. So it says right here, ports in the forwarding state send and receive BPDUs, populate the MAC address table, and forward data frames. A topology change could cause a port to transition from the forwarding state to the blocking state. Next, it says a port in the blocking state discards data frames and does not populate the MAC address table. However, a port in the blocking state can receive BPDUs. If a topology change occurs, the port will again enter the listening state. All right, so that is good information to know. So number 2, it says, what are 2 other states in which a Rapid-PVST plus port can transition? What are the function of those states? All right. So right here it says there are 2 other states with Rapid-PVST plus ports can transition through during network convergence, listening and learning. The listening state is typically displayed in the output of the show spanning tree command as LIS. In the listening state, a port becomes able to send and receive BPDUs, which carry spanning tree protocol information. However, a port in the listening state discards data frames and does not populate the MAC address table. It says the learning state, on the other hand, is typically displayed as LRN. After a port transitions to the learning state, it begins to populate the MAC address table. In addition, a port in the learning state will continue to send and receive BPDUs. However, a port in the learning state will continue to discard data frames. So that's good information to know as well. So number 3, it says issue the commands necessary to disable the root port, which is the Fast Ethernet 00 port. Then repeatedly issue the command necessary to display spanning tree information. What states do the ports transition through? What port roles are selected for the Rapid-PVST plus ports after the network converges? So it's basically going to, we're going to disable the root port and then see what happens. All right. Because we see that the Fast Ethernet 00 port on switch 1 is our root port. So that is our best path to the root bridge. So let's see what happens when we disable that port. So let's do a configure terminal. Let's do an interface Fast Ethernet 00. And let's do a shut. And then let's do a do show spanning tree. And we should see our ports going through the listening state now, which they are. We can see that the port which was the alternate port, which was the Fast Ethernet 02 before, has now transitioned to our root port. All right. It should be to the learning state now, which we are. And then here our network is going to converge here in the next couple of seconds, and then they will be in the forwarding state. As we can see now, all of our ports are now in the forwarding state. All right, so we just watch the network converge and go through the various states with Rapid-PVST plus. So number 4, it says, which of the Rapid-PVST ports on switch 1 could be configured with port fast without increasing the likelihood of creating a spanning tree loop? If we look at our topology, we can see that switch 1 has a end device or end host off of its fast Ethernet, one of its fast Ethernet ports. So because of that, since it's out to a end host and not another layer 2 device such as a switch, we can enable port fast to get this computer online faster. And it would not be a liability of causing a loop because we're not connecting to another switch. We're connecting out to an end device. All right. So number 5, it says issue the command necessary to configure port fast on the fast Ethernet 011 port. What other technology might you typically configure on a port that is configured with port fast? Well, you would also, for safety measures, configure BPDU guard on a port that has port fast enabled. And you would do this in case a user were to unplug this computer and then plug a switch up. If that was the case, then the likelihood of a loop would be high in the network. So if you enable BPDU guard, if this port ever starts receiving BPDUs, which is a type of packet that is sent by another switch, if this port ever receives that BPDU, then this port will be put into the air disable state to prevent a loop from occurring within our network. All right. So let's go ahead and it says issue the command to configure port fast. So let's go and do a let's do an exit. Let's go into the interface for fast Ethernet 011 and let's do a spanning tree port fast. All right, hit enter there. So now it says issue the command to disable and then immediately re-enable the fast Ethernet 01 port. Next, repeatedly issue the show spanning tree command to watch the ports transition through the Rapid-PVST plus states. What difference do you notice about the fast Ethernet 01 port and the fast Ethernet 02 port transition when compared to the fast Ethernet 011 port? All right, so let's go ahead and go back and hit exit. Let's go into the interface for fast Ethernet 01 and let's do a no shut. Okay, well, let's do a shut first. And let's do a no shut. And let's do a do show spanning tree. And as we can see, our fast Ethernet 011 port is already in the forwarding state, and that is because it does not have to go through the listening and learning states. But the fast Ethernet 02 ports have to because port fast is not enabled on those interfaces. And we don't want port fast on those interfaces because the likelihood of a layer 2 loop occurring would tremendously increase. You never want to enable port fast on a port that is connected to another switch. So we just seen that the fast Ethernet 01 and 02, they were first in the listening state. Then we seen them transition to the learning state. Our fast Ethernet 011 port has been up in the forwarding state from the start, and that is because port fast is enabled on that interface. So now if we do it again, our network should be stable and converged, and it is, and we can tell by the state, which is in the forwarding state for each of the ports. All right, so that looks to be the end of this lab. Let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.